All right, in Unit 5A, there are a lot of definitions, so make sure that you write these down with the definition beside them because a lot of your homework is being able to define these words. All right, the two definitions of statistics, if you look at it, statistics is the science of collecting, organizing, and interpreting data. Statistics are the data that describes or summarizes something. So there's two ways you can look at it. Statistics is considered a science in which you find data and interpret it, whatever you find out of it, and statistics are the data that describe and summarize something. The population in a statistical study is the complete set of the people or things being studied. The sample is a subset of the population for which the raw data are actually obtained. So when you can't use the whole population, you'll use sample data. Population parameters are specific numbers describing the characteristics of the population. Sample statistics are numbers describing the characteristics of the sample found by consolidating or summarizing the raw data collected from the sample. And we'll get more into detail into that. For example, population and sample. Describe the population, sample, population parameters, and sample statistics. So we're going to look at a word problem, and you're going to have to be able to distinguish all these parts. All right, so agricultural inspectors for Jefferson County measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn-producing farms in the county. Okay, so to begin with, we have to describe our population. The population here is the inspectors seek to learn about the population of all ears grown in the county. So they're trying to make an assumption about all of them. They do this by studying a sample that consists of 25 ears from each farm. So they're not studying every ear of corn from every 104 farms in the county. They're picking 25 from each of them. The population parameters are the average level of residue from the 3 pesticides on all the corn grown in the county. So the parameters are actually what they're measuring, and that's when they say up here, you're measuring the levels of residue. And that would be your parameters. That's what you're studying. Sample statistics describe the average level of residue that are actually measured on the corn in the sample. The population parameters state what you're doing. The sample statistics are what they're actually going to tell you. When we do the experiment, they are actually going to give you the measure of the levels of residue on all the corn samples. All right, there are basic steps to a statistical study. The first one is you have to state your goal. You have to know what you're trying to find out. Number 2, you have to choose a representative sample from the population. And we'll get more into depth of this when we talk about bias and random. Number 3, you have to collect raw data from the sample and summarize these data by finding sample statistics of interest. 4, you have to use the sample statistics to infer the population parameters. And 5, you have to draw conclusions. Now we're going to look at a visual or a chart that will help you with this. Okay, so if they got this and the elements of statistical study, the start, this is the first thing you do. Identify your goals or what you're trying to find out. And your population. Well, if your population is too big, we have to draw a sample from our population. From this sample, we're going to get all of our data and summarize it. That's where we get our sample statistics. From that, we're going to make inferences about the population, and that would set our population parameters, and then you're going to draw your conclusions. And the reason they've got it set up like this is because a lot of times when you do statistical studies, you have to keep doing statistical studies to see how things change, either over the year, over time, or if there's a major change in the population. All right, for example, unemployment survey. Each month, the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest is the U.S. unemployment rate, defined as the percentage of people who are unemployed among all of those who are either employed or actively seeking employment. Describe how the 5 basic steps of this statistical study apply to this research. Now, I want you to break this down sentence by sentence, and when you separate it into the parts that they give you, it'll be a little bit easier. So the solution, step 1, what are we trying to find out? Okay, so the goal of the research is to learn about the employment or unemployment within the population of all Americans who are either employed or actively seeking. So if we go back, you can find this where it says one of the population parameters, and they have to complete that whole sentence. Okay. Step 2, the Labor Department chooses a sample consisting of people employed or seeking employment in 60,000 households. So they will state the sample that they're picking if they're not using the whole population. 3, the Labor Department asks questions of the people in the sample, and their responses constitute the raw data for the research. The department then consolidates these data into sample statistics such as the percentage of people in the sample who are unemployed. Now notice all of these were stated in that sentence. You're just separating it out into the steps. Number 4, based on the sample statistics, the Labor Department make estimates of the corresponding population parameters, such as the unemployment rate for the entire United States. So they're basing United States information on the parameters set by their sample. And number 5, the Labor Department draws conclusions based on the population parameters and other information. For example, it might use the current and past unemployment rates to draw conclusions about whether jobs are being created or lost. All right, some more definitions. The definition of representative sample. A representative sample is a sample in which the relevant characteristics of the sample members are generally the same as those of the population. This means that when you pick out a sample, let's say we're talking about the people who live in Statesville, you cannot pick just women. You cannot pick just people under 15. It has to represent the whole population, and you have to have a sample or a representative of each group. Common sampling methods. All right, here's a bunch of definitions for you. Simple random sampling. We choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. This is why it's random. You're not looking for specifics, you're just randomly picking. Systematic sampling is we use a simple system to choose the sample, such as selecting every 10th or every 50th member of population. So this would be one where you have a list and you decide you're going to do every 5. So you're doing a systematic sampling of every 5, and that's how you're looking at it. Convenient sampling is we choose a sample that is convenient to select, such as people who happen to be in the same classroom. So if you were going to do a survey, it would be more convenient for you to survey the people in the classroom instead of going on campus and randomly finding people. Okay. Stratified sampling. We use this method when we are concerned about differences among subgroups or strata within a population. We first identify the subgroups and then draw a simple random sample within each subgroup. The total sample consists of all the samples from the individual subgroups. This would be an example of if you were going to survey the Mitchell population. You would look at freshmen, sophomores, juniors, and seniors, and you would want to take groups from each one of them so you know that you have samples throughout the individual population. All right, here is a picture graph to show you the things that we just went over. Simple random sampling, convenient sampling, notice it's who's ever there. Systematic sampling is checking off certain things that you're looking for, 4th one, 5th one, or 3rd one, and this one. Stratification is partitioning the population into at least 2 strata, which is like 2 different categories, and then you draw a sample from each. This could be like the females and the males from the class, and you make sure that you are representing them equally. Identify the type of sampling used in each of the following cases and comment on whether the sample is likely to be representative of the population. So pay close attention to these examples because on your homework, these are a lot of things you're going to do. You're going to have to tell me what sampling method it is. A, you're conducting a survey of students in a dormitory. You choose your sample by knocking on the door of every 10th room. Now, if we go back to our chart, notice we didn't randomly do it. It's not convenient who's next to us. We didn't put people in a group. This is systematic sampling. You're going to every 10th door, okay? Choosing every 10th room makes a systematic sample. The sample may be represented as long as the students are randomly assigned to rooms. If you are in a dorm room with just females, you're not going to represent any males in this. To survey opinions on a proposed new water line, a research firm randomly draws the addresses of 150 homeowners from a public list of homeowners. This record presumably lists all the homeowners, so drawing randomly from the list produces a simple random sample. It is a good chance of being representative of the population. Because it's random, there's no order to it, and there's no bias in it. Agriculture inspectors for Jefferson County check the level of residue of 3 common pesticides on 25 ears of corn from each of the 104 corn-producing farms in the county. Now think about this. You're taking some from each one of the farms. So your farms, each one is a strata. Each farm may have a different pesticide use, so the inspectors consider corn from each farm as a subgroup, or a stratum, from the full population. By checking 25 ears of corn from each of the 104 farms, the inspectors are using stratified sampling. If the ears are collected randomly on each farm, each set of the 25 is likely to be very representative of its farm. Anthropologists determined the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites in southern Europe. Okay, so they're looking at average brain size, and they're going to use skulls that are found at 3 sites already. By studying skulls found at selected sites, the anthropologists are using convenience sample. They have little choice because only a few skulls remain from the many Neanderthals who once lived in Europe. However, it seems reasonable to assume that these skulls are representative of the larger population. Biased. A statistics study suffers from bias if its design or conduct tends to favor certain results. In an observational study, researchers observe or measure characteristics of the sample members but do not attempt to influence or modify these characters. So when you're doing this one, you're not even asking questions, you're not doing giving somebody something to study and see how it affects them. This you're just observing, you're watching. Like if you would sit at a stop sign and watch how many actually stop there. You're not influencing them to stop, you're not doing anything, you're just observing. In an experiment, researchers applied treatment to some or all of the sample members and then observed the effects of the treatment. So in an experiment, this is when you actually give them something or you're going to test something on them. Treatment and control groups. The treatment group is an experiment. In an experiment is the group of sample members who receive the treatment being tested. So let's say we were going to see if a certain pill helped you sleep better at night. This is the group that you would actually give that drug to see if it helped them. Then you have your control group. Your control group in the experiment is the group of sample members who do not receive the treatment being tested. These are the ones that you're going to compare your treatment group to. You're going to see if their sleep patterns change because of the medication, and the control group will receive nothing, so they will continue with their regular sleep patterns. It is important for the treatment and control groups to be selected randomly and to be alike in all aspects except for the treatment. So each one of these groups, nothing else should be different except for the treatment. Placebos and the placebo effect. A placebo lacks the active ingredient of the treatment being tested in a study, but looks and feels enough like the treatment so that participants cannot distinguish whether they are receiving the placebo or the real treatment. Sometimes you give placebos because you don't want which one to be the control group and which one is the experimental group. You don't want them to know which one. So you'll give them a placebo so everybody's taking a test, but the control group is not really getting the pill. They are getting a placebo. The placebo effect refers to the situation in which patients improve simply because they believe they're receiving the useful treatment. Some people, when they get it, all of a sudden they will say that they are getting the effects that you said the treatment would give them. And that's called the placebo effect when they're not really receiving it. Blinding. In statistical terminology, the practice of keeping people in the dark about who is in the treatment group and who is in the control group is called blinding. An experiment is single blind if the participants do not know whether they are the members of the treatment group and the members of the control group, but the experimenters do. So this would be like if you're doing an experiment, the people in your control and your treatment group do not know which group they're in, but you do. The experiment is double-blind if neither the participants nor the experimenters, the people who were administering the treatment, know who belongs to the treatment group and who belongs to the control group. What is wrong with this experiment? For each of the experiments, describe, identify any problems, and explain how the problems could have been avoided. Again, you might want to write this down because in your homework, these are samples of the work that is going to be in there. A chiropractor performs adjustments on 25 patients with back pain. Afterwards, 18 of the patients say they feel better. He concludes that the adjustments are an effective treatment. Well, the 25 patients who received adjustments represent a treatment group, but it lacks a control group because he treated all the patients. The patients may be feeling better because of a placebo effect rather than any real effect of the adjustments. The chiropractor may have improved his study by hiring an actor to do a fake adjustment, one that feels like a real manipulation, but doesn't actually conform to the chiropractor guidelines on the control group. Then he could have compared the results in the two groups to see whether the placebo effect was involved. So he would have taken part of his patients and sent them to the fake chiropractor, and they really wouldn't have got an adjustment, but they would have thought they were. And so if they actually said they feel better, they could have had a placebo effect. What is wrong with this experiment? B. A new drug for a type of attention deficit disorder is supposed to make the affected children less disruptive. Randomly selected children suffering from the disorder are divided into treatment and control groups. Those in the control group receive a placebo that looks just like the real drug. The experiment is single blind. Experimenters interview the children one-on-one to decide whether they become more polite. Because the experimenters know which children receive the real drug, during the interviews they may inadvertently speak differently or interpret behavior differently with these children. The experiment should have been double-blind so that the experimenters conducting the interviews would not have known which children received the real drug and which children received the placebo. So they're saying in here, because the experimenters knew who had the drug and who didn't, they would be biased in how they conducted their interviews. Definition of retrospective study. A retrospective study, or a case control study, is another way to say it, is an observational study that uses data from the past, such as official records or past interviews, and in which the sample naturally divides into a group of cases who engaged in the behavior under the study and a group of controls who did not. For each of the following questions, what type of statistical study is most likely to lead to an answer and why? A. What is the average income of stockbrokers? This would be an observational study. They can tell you the average income because we only need to observe or do a survey on the brokers and look at their incomes. There's no experiment or anything given to them. Do seatbelts save lives? It would be unethical to do an experiment in which some people were told to wear their seatbelts and others were told not to. Instead, we conduct a retrospective study. People who wore seatbelts in crashes represent the cases, and people who did not wear them are the controls. By comparing the death rates and accidents between cases and controls, we can learn whether the seatbelts save lives. They do, by the way. Can lifting weights improve runners' time in a 10-kilometer race? We need an experiment to determine whether lifting weights can improve runners' 10K time. One group of runners will be put on a weightlifting program, and a control group will be asked to stay away from weights. We must try to ensure that all other aspects of their training are similar. Then we can see whether the runners in the lifting group improve their times more than those in the control groups. Note that we can't use blinding in this experiment because there's no way to prevent participants from knowing whether they're lifting weights or not. So the participants here will know whether they're in the control group or the experiment group because they have to lift weights. That's pretty obvious. Can a new herbal remedy reduce the severity of colds? We should do a double-blind experiment in which some participants get the actual remedy while others get a placebo. And we need double-blind conditions because the severity of a cold may be affected by mood or other factors that experimenters may inadvertently influence. So you have to have double-blind in this one so there's no bias from the interviewers. Definition of margin of error. The margin of error is used to describe a confidence interval that is likely to contain true population parameters. A confidence interval is from sample statistics minus the margin of error to sample statistics plus the margin of error. So your confidence interval is like from 1% to another. All right, so an example here is a closed election. An election eve poll finds that 52% of surveyed voters plan to vote for Smith, and she needs a majority, more than 50%, to win without a runoff. The margin of error in the poll is 3%, 3 percentage points. Will she win? Okay, so we have to look at from and to. So we're going to take the 52% and subtract the 3%, so we get from 49%. And then we're going to go to the 52% plus the 3, because the 3% is your margin of error. So it would be 55%. So we can be 95% confident in that the actual percentage of people planning to vote for her is between 49% and 55%. Because this confidence interval leaves open the possibility of either a majority or a less than the majority, the election is too close to call. Because if you'll notice up here, she needs a majority, which is more than 50%. Well, in my interval, I go less than 50% and above 50%. So it's not an exact thing where we can say it's always going to be above 50%. So yes, she will probably win. So it's going to be too close to call.